And we're live. Good morning, good afternoon, good evening, everybody. Again, it's here, it's morning. I got my coffee and I'm super excited. Welcome, everybody. Let me know in the chat where you're tuning in from. Let me know in the chat if it's morning, noon, night, if you got a coffee, if you got a beer. I'm here again for another amazing workshop. I'm here with Dhruvin. We're talking about tokenization today. But before we jump into the presentation, I want to ask Dhruvin a question. I know he's been in the space for a while, and I'd like to know everybody's perspective before they got into the crypto space. I want to know what was their like aha moment. When did they see the value of blockchain and why they got involved? So Dhruvin, welcome to the cast. Let us know what brought you to the space.
Thank you, Joris, for inviting me to this session, and I'm very much excited to talk more on the tokenization. My interest in the blockchain came when I didn't heard anything about blockchain, or I heard about the Bitcoin, but I didn't know the buzzword blockchain before early 2017, and then when I got to know. I started looking into Web3 Ramix, and when I started in that, it was kind of very tough to get inside the space, because there were many of the developers, I mean my developer friends, who just left it just because there was not proper developer tooling. And this is one of the aspect that I'm very much passionate about, of developing the tools for developers. And if you look at my work in blockchain so far, is surrounded building the tools for blockchain, may it be the MetaMask version for Eon network, MetaMask for Polkadot network. It is surrounded developer tools. So that is one of the aspect. Another aspect is, yes, I am very much fond of decentralization and the concept of decentralization, and that is the essence of what Bitcoin and Ethereum networks are founded for. So that is basically my background, and my reason for interest into the blockchain space.
Amazing. I always love hearing like the perspective that people come at the space with, because it's going to and has already begun to affect every kind of industry. So it seems like you're coming at it from a bit more from the technological side. You're a developer yourself, so the tech is what interests you, and then there's like entrepreneurs that come in and see the business applications, and then we need designers that are interested in making it more accessible. It's very interesting seeing the angle that people come at this industry from. Well, I want to thank you very much for being here. I see folks are have begun trickling in. We have a great audience today. And to the audience, I want to mention before we just jump into the presentation, take a look down at the bottom of your screen. You'll see an Ask a Question button. If you have any questions during your presentation, feel free to click on that button, type in your question. If you see a question already there that you want to get answered, make sure you upvote it, and we'll get to those questions either during the presentation, or we'll have a Q&A section at the end. Right beside that is a polls button. I'm going to be putting up a poll there, so keep an eye for a notification there to answer our polls. And I think that is about it for me. I'm going to make myself scarce. So I'd like everybody to give a nice digital welcome to Dhruvin. He is a senior blockchain developer at Capital Methods. He's diligent in writing clean, bug-free, well-documented, and well-tested code, mainly in React, React Native, and Node. He has contributed to open source blockchain projects like Iowa, Enzyme, and Hopper. He's professor as well as curriculum developer at George Brown College and York University for their blockchain development program, and he specializes in creating and delivering content for full stack web development using Node and React, as well as smart contracts and decentralized applications. So everybody, please help me welcome Dhruvin to the cast, and on that, I will make myself scarce, and you can take over by sharing your screen there, Dhruvin.
Okay, thanks, Joris. Great. So, hi everyone. Thank you so much for having me and joining this workshop on tokenization. There is so much material to cover that I don't have enough time today to go over the basics of blockchain. I'm going to assume most of you have the basic understanding of the blockchain, so we can move on to some of the introduction slides. So great. My name is Dhruvin Parikh and I am a senior developer at Capital Methods, where I help build next generation yield aggregator for DeFi platforms. I am also responsible for teaching and setting curriculum at York University and George Brown College. Before that, I worked with startups and write code to try to make things happen there. So what we are going to cover is overview of the transactions in Bitcoin and Ethereum, what tokenization is, why is it useful, and what are its use cases. We are going to get on 4 specific tokenization strategies. We are going to talk about token design. How can we think about creating a token, structuring it, and making sure that there is economic value there? And of course, how do you get involved? So let us start with a primer on blockchain. A blockchain is a distributed database. Everyone agrees on a basic set of rules about how it can be changed. For example, the rule can be only owner of an account can send transactions from that account. When a blockchain is working properly, everyone in the world has exact same copy of the database. How this happens is called consensus protocol. When applying a transaction to the database, everyone in the world must get the same resulting database. So all the transactions must be deterministic, which means it cannot get input from outside world. It cannot depend on anything except what is already in the DB, and it cannot generate random numbers. So Bitcoin uses unspent transaction outputs, which means your balance doesn't exist in one place. It sums all the unspent checks you have received. Whereas Ethereum uses accounts, which means your balance exists in a single record in a database. The first significant difference between the two balance model is how the state of the system is recorded. In the UTXO model, the movements of assets is recorded as a directed acyclic graph, which is also known as DAG, between addresses, whereas the account model maintains a database of the network states. A graph is defined as a set of nodes or vertices connected by edges. In a directed graph, each edge has a direction, usually indicated through arrows. Directed acyclic graph doesn't allow circular relationships between nodes. The graph above shows a directed acyclic graph of the UTXO model, which is on the left. Each state represents a block in the blockchain. Each transaction output comprises a node in the DAG, and each transaction is represented by one or more edges originated from a transaction output. Hence, an unspent transaction output, or UTXO, does not have an edge originating from it. So in the example above, the transaction outputs 3, 5, 6, and 7 are unspent. Whereas on the right, the graphic shows a representation of different states in the account model. With each new block, the state of the system is updated according to the transactions contained in the block. The number of accounts remain constant and dependent of the number of transactions conducted, as long as number of users or smart contracts remains constant. In the UTXO model, the entire graph of transaction outputs spent and unspent represents the global state. In the account model, only the current state of accounts and their balances represents the global state. In the example above, this is the set of accounts A, B, and C and their respective balances. Balance T0, T1, 2, T3. The conceptual difference is that account model updates user balances globally. The UTXO model only records transaction receipts. In the UTXO model, account balances are calculated on the client side by adding up the available unspent transaction outputs, or UTXOs. So in the real world, the UTXOs are almost similar to physical cash coins. When one tries to spend cash in a shop, he gives up the entire bill, takes the goods, and takes back the remaining change. If one has a bill of $10 and want to buy good price $5, he doesn't divide the note in half for the payment. Rather, he gives up the full note and takes $5 note as a change along with the goods. UTXOs work in the similar fashion. In a transaction, UTXOs are always consumed in full, even if the required payment is of the partial value of the original UTXO. For example, suppose Alice wants to pay Bob for some goods or services which cost 6 Bitcoin, but Alice only has a single UTXO of 10 BTC. She will create a transaction that will consume up this whole UTXO of 10 BTC and create two new UTXOs, one for Bob with 6 BTC and one for herself with 4 BTC value. The UTXO Alice pays to herself is known as the change UTXO, and her wallet software automatically tracks this UTXO to give her the final balance of 4 BTC. Every time a payment is made for a smaller value than available UTXOs, the wallet automatically creates the change UTXO for the user. So, account model in Ethereum. So each account has a counter and each transaction has a sequence number. To apply a transactions, its sequence number must be the next counter number. After applying the transaction, the account counter is increased by 1. So if you are going to use the same nonce again and again, then it's going to fail, saying that the transaction with the nonce number 4 as shown in the example, with the nonce number 3 as shown in the example, has already been used. So type of Ethereum account. So there are two types of Ethereum accounts: externally owned accounts, abbreviated as EOA, which is a normal public key value pair account, and a contract, which do not have a key value pair. Instead, they have a code written by the contract creators, and they have no ability to initiate transactions. They can only respond to external events. So the Ethereum transaction structure, nonce. It ensures transaction applies in expected order and also protects against replay attack. 2 is the address to which we are sending some value of ether or data to. Init or data. So init field will contain the initialization codes that sets up the smart contract, and the data field will contain the parameters of the message. Resource limits. In order to prevent a transaction from consuming excessive resources, transactions are required to pay fees proportional to how much they consume. In Bitcoin, the fee is based on transaction size. Ethereum is more complicated. It uses gas accounting. The transaction must pay the sum of all gases it uses times the gas price it offered to you to pay. So we are not going to get too deep in what makes something a currency here, and just use a simple definition that currencies are primary medium of exchange. Many online merchants are starting to accept cryptocurrencies like Bitcoin. In addition, traditional currencies for online goods and services. Cryptocurrencies are currencies that are secured by cryptography and blockchain technology rather than governments, and they are sometimes referred to as native tokens. In this case, a native token refers to a primary unit of account of a blockchain. Bitcoin is the native token of Bitcoin blockchain, where the token is understood to be a representation of value or electronic cash as described in the Bitcoin white paper. You may have heard the term altcoins as well. This just refers to the fact that Bitcoin was original cryptocurrency and all that come after are alternatives to Bitcoin. While true that other altcoins can be used to transfer value, many of them have additional features to Bitcoin as well. Take Ether, for example, which is the native token of Ethereum blockchain. Ether is not only used as a cryptocurrency, it also powers the execution of decentralized application on the Ethereum blockchain. Moving on, let's just agree on a definition. So there is a lot of discussions about tokens, tokenization, token this, token that, enabled decentralized economy. So there is a lot of talk about tokens. I think the best thing that we can do is agree on one definition that we can work off with. If we disagree with the definition, of course, feel free to reach out after and I'm happy to discuss with you. But for now, let's just go with this definition. So a token is an unreproducible, verifiable digital record that represents a metered resource. They are often implemented via smart contracts, software collectively run by a network of computers. Tokens are more general than cryptocurrencies. They are just representations of assets and don't necessarily have to be a medium of exchange, although they can be. For example, DAI is a stable coin, which is a digital token representing a dollar on Ethereum, which is a US dollar. Tokens are often built on top of blockchain that also have one or more cryptocurrencies associated with them. For example, Ether supports Ether, which is its native token, but it also supports many other tokens defined in the form of a smart contract. So smart contracts are software programs running on a blockchain that inherit many of the security and authenticity guarantees of the underlying blockchain. There are actually multiple kinds of tokens. There are cryptocurrencies like Bitcoin and Ether that are main crypto assets of their respective blockchain. Bitcoin, which is just a representation of value, is different than Ether, which also powers the Ethereum blockchain, and demand is driven more by decentralized application developers and the users. Tokens that are enabled by Ethereum often have some utility other than a currency, but maybe not, as in the case of stablecoins. So token engineering would be trying to glue these tokens, that is, these digital artifacts, which are unreproducible, verifiable digital records, to that what they are supposed to represent. I can create billions of tokens over my coffee break, but no one would believe me if I said that each token represents a bar filled. So there are many layers of security that we have to create to convincingly represent a unit of value, whether it is common stock, bonds, voting rights, physical assets, or some kind of digital scarcity backed by the consensus algorithm. So this layer of security includes leaning on real-world legal contracts that are valid across multiple jurisdictions in the governments. Crypto economic security, which is at high waterline for financial costs, that needs to be breached for anyone who can think of conducting an attack. It incorporates cryptographic security, which converts digital ownership in the form of private keys and even physical securities, if we have some custodian elements. So let's dig deeper into this great idea of tokenization. Tokenization is a conversion of an asset into a token that can be recorded, stored, and moved on a blockchain system where the blockchain provides secure, immutable record of ownership, and updating the record on blockchain is easier than physically transferring the ownership. So given this definition of tokenization, what is a token again? So as I mentioned previously, it is just an unreproducible, verifiable digital record. Blockchain technology is well suited to maintain unreproducible, verifiable digital records, hence the increase in interest in the tokenization, along with the rise of Bitcoin and Ethereum. So we are going to get into one relevant example. So casino chips, not quite a token on blockchain, but I think they are useful to start with because they exhibit many similarities with the benefit that you see with the tokenization. So yes, casino chips deals with gambling, but the point that I'm trying to make to look at the real economic business benefits of the casino chips. So for example, they are engineered with better security, behavioral benefits, and convenience. But if they are stolen, for example, then it cannot be accepted as a legal tender anywhere else. And it is difficult to trace from where it came from, making them very less attractive to steal. Regulators can set regulations for casino chip standards because all casinos protect consumers wholesale. And lastly, because they are slightly diverse from cash, some people say that they create more engagement and enjoyment for the casino goers. So with tokenization, we can just start out gates with many of these benefits, just pre-programmed. Software can be used for building block with really low cost. Another example that has some benefit which intersect with the tokenization is the stock. A common share stock is another example that leverages many benefits. It's just done in a doc way. Like all these structures and facilities were built around issuing shares and ensuring their integrity. Issuance was originally done with paper certificates. Today, most of the trading activities is now digital. If we talk about US, it is ownership, and the governance model relies on a central secured repository known as repository trust company. It retains custody of over 50 trillion of assets for faster settlement and better security. These are the benefits that we can now also achieve with tokenization using cryptography, shredded business logic, and network value. The security industries is perpetually evolving. For example, employee stock options did not become popular until early 1980s. One of the questions today is what possible that we have gone from paper certificates to database entries. Software tokens that can be legally represent the asset and evolve over its entire life cycle. So as a core technologies, this building block can reduce time to market, allow to do things, structure regulatory compliance to the asset itself, irrespective of where it trades. So I like to use internet analogy for many things related to blockchain. And I think it makes sense here as well. Before the internet, information was largely siloed in individual computers, databases, or small computer networks. The creation of the internet largely was the development of ideas and standards around how computers could transform information reliably, efficiently, and quickly. It's helpful to think about tokenization doing for physical assets and value what the internet did for information. This is the digitization of new classes of things with token standards for how digital assets behave. They will become more accessible, tradable, and efficient, and complex asset systems can be built. Not only are trades settled more quickly than existing systems, but it is more easier for the people to create software that handles these tokens. This lowers the barrier to entry for creating and experimenting with products that handle value in a novel way. This will spur innovation in the financial sector like we haven't seen before. So speaking out about now what's possible, right? One big theme in tokenization is the reduction of transaction costs, and the real estate market is a great way to illustrate this. So today, there is no national real estate exchange of meaningful size or activity. Market is largely bilateral, which means brokers matchmake buyers and sellers per transaction. And it's subject to non-market process such as social value of the home ownership, and each parcel is very unique and beautiful with its own snowflake. Apart from that, people generally want to see properties in person before they buy them, and some economists claim that these factors add up to the transaction cost when you are trying to buy. and sell these things, and makes it very difficult to achieve the critical mass you need for the efficient exchange. So this sounds amazing. So what's the holdup? Creating standard interfaces for how tokens should behave is crucial, right? And we are still in the design and experimentation phase. If we are going to build a global settlement layer for tokenized assets, we need to get it right the first time. We want to change or upgrade a system that is actively managing a significant portion of a global wealth. Once standards are published, developers need to learn how to interact with them and use them properly, and it's gonna take some time. There have already been many token standards published on Ethereum, including the popular ERC20 and ERC721 standards, but many newer standards are being developed and adopted by the community as well. So with this regards to the regulation, there is still a lot of uncertainty around how blockchain-based assets are going to be recognized by the government around the world. Luckily, with the large increase in the value of overall cryptocurrency market and ICO boom in 2017, legislators started taking this technology more seriously and have been making progress on this front. Still, this is complex technology, and best way forward is not totally clear. Naturally, lawmakers are lagging behind the development of technology because they have hard questions to address. So lastly, just a note on scalability. Scaling blockchains is in a secure, decentralized way has been a topic of discussion for a few years. I mentioned this point because it has been brought up so many times in the past. My perspective is that there are many highly talented, well-funded individuals and teams working on this problem across the ecosystem. Scaling solutions like Plasma, state channels, and zero-knowledge rollup are already here, and others like sharding are coming, and the latest one is the optimization, which is there is a lot of hype around that to increase the transaction for all the popular DeFi platforms. I think creating good agreed upon token standards and getting clarity from regulators are bigger hurdles to overcome. So why issue a token or digitize assets into the token? So let's talk a little bit about why we might issue a token. Some of the benefit that it confirm. The first one is something that is highly touted, the near time clearing and settlement. As seen with Bitcoin and Ether, asset clearing is fast and final. Global transactions can be settled by anyone with certainty within seconds to minutes. If we build this into smaller and more focused networks, the benefits of known participant even stronger and faster guarantees are possible. Because tokenized systems are built using modern cryptography and cryptography security from the outset, fine-grained permissioning, tamper resistance, and data privacy can be tuned at every level of an application. For example, both consensus implementation and JP Morgan's quorum implementation, both are implementation of Ethereum and incorporate permissioning and cryptography that enterprise needs. Asset ownership exists on famous decentralized ledger technology, which covers full audit trail. It can also be permission to make sure that authorized access can see a specific transaction. So network of values, a core difference between tokens and sending trades around today electronically is that settlement happens at a set transaction level instead of a new expansive responsibility for trading agent. This means that settlement and compliance costs are efficiently borne by the market, so it's far easier to onboard new participants with low barrier to entry. Network forming, the formation, and maintenance become a lot faster and cheaper, and the shift and responsibility also sets foundation to allow a cross network exchange. So tokens are shared business logic. So tokens are software. They can be programmed with the business logic that travels with assets. This can be inspected by all necessary parties, including regulators to ensure fair play. And lastly, high-level controls. Due to their orchestration of the shared ledgers, the management of the tokens are simplified. Market structuring can be transparently incorporated as clear-cut software rules. This means that if there is a newly created rule for the market, we can enforce it across whole market with an audited software updated instead of trying to contact every market participant to get them to do the new thing. So a question is there any way to tokenize physical asset? So tokenizing physical asset, you can look at some of the projects that are tokenizing gold. For example, the digitize project has token representing 1 gram of gold, and I think depository institution is in Singapore. So there are centralization risk of that model, but there are tokens that have booked value in the market. It's pretty locked up with the gold, so it is more involved in that you have to figure out what the governance and regulatory criteria are, and you you definitely need to work with a very strong legal team and right kind of technologies for that. But it is possible to tokenize a physical asset. Great. So tokens across scopes. So if basically we have a pretty broad definition of token at any time or exploring a new technology or new way of doing things, we really want to just be open about it. So we want to consider the existing assets that have those properties. So we can just look at those economic models and have a very good discussion about it, and should not be too dogmatic in our beliefs. So we see tokens existing across this all different scope. For example, we have some tokens on the public blockchain. These are some popular projects like Bitcoin, Ethereum. 0x is the decentralized exchange, but the token Dogecoin, which is a fork of Bitcoin, speaks to how can anyone create assets and distribute it globally. Augur is a prediction market for consortium blockchain. We see JP Morgan announced their coin, which will not be available for public use, to my knowledge, but is used within their network of banks to facilitate transactions. And within single enterprises, the digital artifacts that represents some meter resource from online games, EU Online to QQ, which has one of the first virtual currencies, and also loyalty points can be used to buy things within an ecosystem. Great. So where do you want to place the tokens in all these different scopes? We have the public blockchain, consortium blockchain, or maybe we just need a centralized database and not even a blockchain. That's always a very important consideration. And another question to ask for you is issuing a digital asset and tokenizing it. Is there any existing trusted clearinghouse that can already do asset lifecycle management? If it can do it quickly enough, if you can do securely, transparently, and meet the governance requirements we have, and we should consider using that clearinghouse, right? So you need to trade the asset globally. For example, you might want a public blockchain, or if you don't want every single transaction or its amount to be visible to everyone, there will be these things called zero knowledge proof that can help censor that information while allowing people to verify that it actually exists. Zero knowledge proofs can be incorporated within consortium blockchain or all public blockchains. And if you want trades to be within private membership, consortium blockchain could be a good answer. But again, let's consider a central database, see if it fit our need, because that may be a great solution as well. So given these properties of blockchain and tokenization, where is opportunity? So I see three domains where tokenization is particularly relevant. First is in intangibles. This includes things like patents, copyright, branding, and intellectual property. Tokens can be used to represent rights to participate in governance of a particular system or organization. Tokenization is helpful here because it gives form to ephemeral ideas. It makes it easier to share, trade, and attribute rights to the token holders. So one thing that we need to really think about when we are thinking about tokens is the fungibility. Tokens may be fungible or non-fungible, but what is fungibility? It's a property of a good or commodity of having the units that are interchangeable and indistinguishable. Basically, a dollar, I mean a US dollar, if I have cash more or less, people don't care which US dollar they have. It's pretty fungible. Shares, stocks are pretty fungible. But fungibility does exist on a spectrum as we get to non-fungible. Finding a higher is a very involved thing. Just because you are paying the same salary for someone as you would do for a commodity does not mean you are going to get the same quality of work or fit in the workplace. And art is even more towards that direction. So in a cryptocurrency world and the world of blockchains, I am on a public blockchain network. We can already look at across the spectrum of fungibility. For example, Bitcoin is pretty fungible. It doesn't matter more or less what Bitcoin you have unlisted. It's from a blacklisted address for anti-money laundering or whatnot. You don't want to own those tokens. No one will accept them from you or want to trade them with you. Zcash is a cryptocurrency focused on anonymity, meaning that you can really trace back where this came from. You can just verify that someone has sent and can send a certain amount of Zcash. And that would actually be more fungible. You don't have that restriction, but of course, there are border regulatory questions too. And on the non-fungible side, we have CryptoKitties, which are digital collectible cats that are unique and can evolve and have children. And it is a very interesting game. These cats sell for tens of thousands of dollars now. So a lot of people say, including Clean Christensen, who is the author of Innovator's Dilemma, most of these technologies start looking these silly games until they improve to the point where it's hard to ignore them. As we are seeing a lot of games take off in the blockchain today, and with tokens especially. So we are going to go over some broad categories and use cases of tokenization. Everyone is kind of like, can I tokenize this? Can I tokenize that? But I think it is very important to look at the underlying economic structuring, like how does this provide benefit? How can we do something cheaper? Is that good at all? How do we do it today? How might we do it with the tokenization? So one example is smaller units of values. The thesis is that smaller transaction costs, such as through technology or better institution, allow for smaller transaction sizes. So why would we want smaller transaction sizes? Well, for example, some stocks get so expensive and save hundreds of dollars that it's hard for individual or some small investors don't own them. So the company will explore something known as stock split, where they create more shares, but it basically maintains the same sum of prices or in market cap. Real estate investment trust are another way that we create smaller units of values instead of buying a whole building as a real estate investor and taking that black swan risk of that building collapsing or something without proper insurance that you might buy into real estate investments trust, which is basically a basket of these properties that you can use to hedge your risk. So what is possible now that we have the technology to do with these guarantees is we can have micro shares of stocks. There are many startups right now just trying to take a share of Berkshire Hathaway or Apple, or something that's pretty expensive and producing very small slices of them as micro shares, and therefore it would be possible for anyone in the world, not just people in wealthy countries, to own a share stock. Whether that's a good idea for society is more of a politics and governance question, and it's important that one that we address. But the point is that technology makes it possible. Another example is fractionalized real estate, and basically, instead of owning a small sliver of a basket of properties, what if we own a small sliver of an individual property, right? If we have reduction in transaction costs to the point where we can issue these contracts and digital form for real pieces of property, it could be possible to own a small piece of one. It's important also to examine some of the risks here, because it might be case that the building closes out as something bad happens to the building, and now that you have taken this short of a long-term risk, and there again the point is like this is possible now, and we have to think through. So what's the actual use case? Who does it benefit? How do we control any risks? And it could be very beneficial in some situations. For example, one opportunity is allowing fractionalized ownership to confer maybe membership of building access. So micropayments. Anyone today using credit cards in US charge, I think, tens of cents plus 2% on fees, making smaller transactions prohibitive. If you want to pay with online payment system, you're kind of assuming that everyone else is on that network as well. So if everyone is on the blockchain network or in transact with cryptocurrency address, then it could be the best way to send micropayments cheaply and reliably to anyone in the world. We see HTC and Samsung already set up, they have already stepped up the massive option efforts by incorporating this cryptocurrency wallets into the devices themselves with hardware security and all that stuff. So let's look at some of the benefits that we discussed earlier and how they apply to the situations. This specific example of smaller units of value, so near real-time clearing and settlement, will be important if people want to be able to trade these things, these things pretty simply. Network of value. If we can easily work at a straight together, so you can bring people together to trade without excessive due diligence on their part B's that handled by network, that could be very interesting proposition. And verifiable digital ownership and history allows people to feel secure in their actual ownership of this, and not trusting like a small entity or something that might go bankrupt. This is also the fundamental regulatory compliance. We contract to complete history, because if we are looking at anti-money laundering, and if we are looking at know your customer, like these facts become important. So another example is exchange within ecosystem. As we discussed with the casino chips before, we see that there's some certain advantages such as security guarantees, improving the user experience, and giving more control over the assets. Swift is another network that tries to facilitate interbank exchange. They have a common technology protocol and everything that allow the qualified banks to talk to each other. We also have loyalty points, which is the network usually with anchors such as Delta that allows other partners and merchants to participate, and you can spend your loyalty points there. Because we are shifting the conversation, and we are saying that like the business logic and transferability is tied to asset itself, it can be a lot more inclusive and a lot more low maintenance for participation to adhere to the same kind of compliance and same kind of quality of transaction that we expect. For example, Formula One just sold an official digital collectible car on Ethereum blockchain for $100,000. That was new value tied to their brand, but was unnaturalized before. Now that they didn't have to bootstrap their own network, they had just Ethereum as an infrastructure layer to work off. They could easily write the smart contract with the developer tooling. And the issue is with security guarantees. Another example is open banking with tokenized assets. Now, open banking is a phenomenon where banks are opening up their APIs. It doesn't really necessarily have to do with blockchain, but if we have tokenized assets, where again the compliance sense, regulations, and business logic follows the asset itself, this clearly reduces the barrier to entry that a small bank, for example, would need to participate in such a network that they can focus on what they do best, such as vetting customers and providing excellent user experience. So just a review of benefits that are highlighted here. Basically, we see that we have this network of value that can just be viewed together very easily. We have shared business logic that can track the asset, and they can just behave the same and comply with regulations no matter where it is. And also because everything happens on a ledger, we can have higher order controls that we are not very possible for. So what if you could identify risk across all the asset transfers, right? And what if regulators had that privilege and you could set the security so that individual firms wouldn't have the whole picture, but someone like a regulatory authority could go and manage risk. So a bit of a broader example. One of the premises is that cheaper tracking and measurement allows more externalities to be measured and managed. Now it's gonna be just blocking that improves this. We already see smaller, cheaper sensors that allow for a more granular tracking of things, but being able to consolidate to a single network of exchange rate, that really help us to able to do more things. So let's talk about an externality in the first place, right? So an externality is their costs or benefit that affect a third party who did not choose to incur that cost or benefit. So for example, carbon credits, they are trying to offset pollution effects by industries that don't necessarily pay for the carbon. Damn it, because it has short of long-term impact in the environment. That's hard to measure. So people were thinking about how do we offset these externalities by issuance of carbon credits and encouraging the behavior where you offset your own costs. It's possible that earned income tax credits can be seen as a way to try to control externality of socioeconomics, not working out in a country and trying to provide benefit for the hard workers who have happened to be in bad economic situations. So for example, if you are driving a car, right, and you are using a road a lot, and maybe you are producing a lot of emissions, currently there is no really a great way at granular level to tackle that problem. There are regulations about cars and roads, but a lot of economists have talked about what would it be like to have a road at a usage fee. Maybe everyone in a city gets a basic allotment of their use of the road, but if they are using it very heavily, perhaps they should have to pay for something. Maybe if people come from out of town, like business trucking things, they perhaps should have to pay for road usage of increased damage and for this public good. And same thing with emissions. If we can track them at vehicle level, we can do a lot of more to manage it. Another example from a different area is financing for real-time inventory risk. A real popular idea is that there are a lot of manufacturers with raw materials just sitting in silos that inventory risk, and this could be a depreciating asset. That's right, and it's not necessarily their job to know where the market's gonna go for that asset that they are holding up if it's just used in their production, right? So typically you can buy insurance or figure out some kind of financial hedge to do this in aggregate level, but you can tokenize something like a chemical that has so many leaders of some very volatile in price chemicals. Then it's possible to better spread the risk across people who are actually better positions to take those risks, such as some financial institutions. So the property that we would be using here is cryptographic security. We can do a lot too. For example, at device level, if we would look at trusted execution environment for cars, we can ascertain that something came from a specific car. This can be used in tandem with other environments and cause this whole chain of custody to be pretty solid, verifiable digital ownership and history that just reduces our accounting costs and high level control, which allow us to know to now take these tokens and manage them into some regulatory or governance framework. So there is a lot of hype around the decentralized finance right now, and the reason that is covered here is it's a very heavy use case of tokenization. So decentralization or DeFi is one of the main applications, or it's becoming one of the main application of the smart contracts. It is an ecosystem comprised of application for facilitation of lending, borrowing, or trading with financial instruments built on decentralized networks. This applications run on a code that promises to return to one token in exchange for another, and will do exactly without failure, without theft, and without people in the middle. So this open finance application are being built almost exclusively on Ethereum. The core principle is to provide a new permissionless financial ecosystem without a central authority. This allows for lending and borrowing in a decentralized manner where users act as their own custodian, maintaining full control of their assets while granting access to the financial services. So if we do a little bit deeper into the DeFi use case, as it has been such staggering growth over 3 months, this chart is kind of hard to see, but it shows that as of mid-August, there was just over 2 billion USD worth of Ether locked in decentralized finance applications on Ethereum. And according to DeFiPulse.com, as of October 16, there is 11.5 billion USD worth of Ether locked in DeFi applications. Both of these sources indicate that majority of Ether locked in DeFi applications is being used to, borrow DAI stable token, indicating a large demand for less volatile crypto asset. Great. So we are going to talk a little bit about token design now. What is the process of bringing a new token into existence? What are the considerations I think are useful? And of course, this is an actively evolving field. So I'm just sharing my understanding after a bit of exploration. What is the actual benefit of having a token? The last thing I want is to issue tokens that don't do anything. It just kind of sits there because that would just be a waste of effort. So token design is a process of starting with real world problems and synthesizing solution using smart contracts, shared data layers, and incentive system. Let's remember that tokens are smart contracts, that how they help get implemented. Many problems aren't a good fit for tokenization. Maybe we just don't need that, or there's an easier way, and it's important to look at that way as well. So the 4 pillars that I came across are market design, customer development, protocol architecture, and distribution. Market design is concerned with establishing new markets and improving existing ones. Customer development is ensuring ensuring that there's sufficient market opportunity in demand, and protocol architecture is how do we build it, and distribution is how do we make sure that the right people get these tokens and are actively using them. Great. So market design is emerging field in economics, and basically its goal are to create better markets. It identifies why are market important with tokens at all. If you're creating these new assets, then it's important that they actually see that they are supposed to do the job and they need the necessary environmental conditions for that to happen. And the whole field of market design investigates how do we make that happen, what's actually important. Market design says that thickness, congestion, and safety are important. So thickness is basically having enough buyers and sellers or participants for it to be interesting. No one wants to drive an Uber in small town where people can just roam on foot, and no one wants to set up Uber if there are no potential riders. No one wants to go to eBay if there are no items for listing, and no one wants to list their items on eBay unless there are enough people coming to look at the goods so that they can possibly have a sale. So you need sufficient thickness to ensure activity. This is also known as critical mass. So critical mass was actually used in physics, which referred to how many grams of radioactive element you needed to continue a nuclear reaction. And you need the same kind of thing if you are trying to design one of the ecosystems that are self-sustaining. So next one is the congestion. When you have too much thickness, then it's going to be very difficult to wean out what transactions are actually relevant to you. For example, going back to eBay, we see that there are filtering capabilities. So you can actually find transactions you are looking for. The real problem with congestion is that participants in a market are presented with too many options, too many decisions they can make, and therefore they're acting on partial information. So you don't necessarily get the best outcome. And lastly, safety. It's really important to engineer sufficient safety. We mentioned digits before. Safety engineering here might have to do with making sure that legal contracts hold water. They might have having a stable coin be safe, might mean having a certified public auditor just come in and ensure that there's some assets backing that stable coin, or there are no liens against those assets, things that improve the confidence of that asset. Safety can mean other things too, like having proper security or good user experience. There's something known as incentive compatibility, which means that when you decide that you want to do something, you just do it and that's fine. There are many school systems where you want to get your kid into school. You can put that as your top option. You have to game the system a little bit, and that is a very uncomfortable behavior. And you know that reduces people's ability to transact confidently, safely, and therefore it's going to affect thickness as well as so these are really important to think about whenever we are designing this underlying market structure for tokens. So customer development is also phenomenally important, no doubt, related to market design as well. But basically, we can view each token as its own product with its own set of users. Maybe it's one user, maybe it's several users that will use this token, but it's critically that we map out exactly what is the economic benefit or other benefit to these users and how will they interact with the set. Do we imagine like any other products like this is the opposite? If we build it, they will come. That approach generally doesn't work for building anything new, from startups to corporate ventures to new product lines. It's really important that we always keep the customer front and center and make sure that it will actually improve their lives. Otherwise, we won't see use and we are going to waste a lot of effort. So a lot of same tools are relevant here. Protocol architecture is how to actually build it right, and this can be subsidized by using existing technologies. There are some on the market today that can reduce time to market, but also like if we are trying to tokenize something, let's say we are trying to tokenize agriculture. If we are trying to figure out what if there's maybe a country without an existing commodities, market, and we want to tokenize the commodities so they can be traded. OTC, that is just without an exchange in place, and there's a lot of consideration, not just technical, although technical parts of it, but also dealing with regulatory requirements and figuring out how do we actually mandate ownership over an asset, which means what kind of private key schemes do we have to use. People even know how to use private keys in our industry. Are we going to look at different approach? And this is really important, just to again go from customer requirements, customer development, and iterate using okay, what's available in the market now, how can we build this, how do we get those security requirements met. So there are many trade-offs. For example, engineers know that you have to choose between things like consistency and performance, security and convenience, equity and efficiency, on-chain versus off-chain. Not everything should be on the public blockchain. If everything is visible to everyone, that could be very horrible, especially for many businesses. So picking the right balances, maybe there's some kind of settlement that you ultimately need to demonstrate, but you can redirect all the information otherwise, or maybe you do have this public and global assets that may be traded by anyone, which could be a good case. This was sort of related to the scoping discussion we had, and also what platform do we want to use. Maybe there are a lot of platforms out there, each with their benefits. It's important to just evaluate all of them and not just grab one. So distribution is just ensuring tokens end up in right hands, and it's an offering that's equitable to market and participants. This is where we engage with a highly skilled legal team and understand what are our actual business regulatory implications. Are we actually going to have a token sale at all? Maybe there's a different distribution method. Maybe, for example, if we are running in an exchange, we can just give existing members of exchange the exchange token or something. We have to think through this. How many tokens are there in existence? If it's tied one to an asset, and that's easy. If you have fluctuating supply, why do we have a fluctuating supply? What benefits does this accrue? Does it mitigate our risk? What about the new risk we introduce? So governance and accountability are very important to this, because again, like without having an agreement with a consortium about what an asset is or what it means to tokenize something, it's really hard to get sufficient traction. So we are just going to get a little bit technical for this last few slides. Just so you understand some of the jargon going around the space, it's actually not that complex. ERC20 is a term that you are going to hear a lot, or you probably have. They are just tokens which are tradable and fungible, especially they are just computer programs. They have functions for each of these things. The report that total supply, which can change. The report specific account balances. They can pre-authorize transfers. They can transfer token to and from addresses. That's it. If you implement those interfaces in a smart contract, then you can have an ERC20 token. So this is why you can create them so quickly. Of course, you have to do the due diligence and auditing and working with probably a software security company. It's a great idea, but ultimately it's a simple concept. So ERC 721, remember the spectrum of fungible and non-fungible. These are a non-fungible side. Each token is its own entity. It can have a complete lineage. And how do we do this is supporting all the functions from your ERC20, but also adding a special token ID and allowing us to add custom properties which can create the uniqueness. So for the Formula One project, which I am not very familiar with, but I would imagine they would basically create custom properties that denote which car it's referring to, when it was created, etc. And this can evolve over time and be changed. So for interoperability, Basically, if you design smart contract based tokens to these standards, then anything that can operate an ERC20 token can now operate your token. Same thing with ERC721, because it just expects things that have this certain functions defined and start to do that. So token taxonomy is still actively emerging and under active discovery. The regulations are shifting and exciting, but most assets today are decided on a case by case basis. But through several jurisdictions are beginning to issue real guidance. There are kind of uncertainty and rulings right now, but that's getting figured out pretty quickly as of late, especially. And there's a massive opportunity here to reinvent the core components of financial system to be fully digital, global, and equitable. Great. So let's talk about how can you get involved. If you are not interested in buying anything, which is totally fine. So the goal behind the token taxonomy initiative is really to educate, to create token definitions, to define metadata, and create standard methods of mapping these characteristics. I believe this provides better understanding of each token's unique characteristic and their behaviors, so they can be better classified as either security is triple currencies or currencies and commodities. And on top of that, new rules and regulations can be written to any of these edge cases, or if the token, if it more changes over time. This is not meant to blockchain specific, and it's not really a framework, but more of a common ground that was proposed by Microsoft and presented to the participants. Here's a high level view of what token taxonomy looks like. There's a set of formulas that are created in order to easily label a token and a higher group of categories. So this would be much more granular than simply saying we have a lot limited number of grouping of token types, and so it does include a range of fungible and non-fungible. But the other characteristic that you see on the right side can really create the formula and define different layers, so you can better expect and understand what the life cycle of a token would be. So when I mentioned earlier the fungible and the non-fungible tokens, this is just the initial layer, and below that you can see this is just an example of hierarchy where we can map the different characteristics that inherit these functions. So in the stock example on the bottom middle, you have a variable quantity, which is a whole fungible token. This can be broken down even further during the designs. And one of the goals for creating this hierarchy and this formula is really to build an easier visualization tool with detailed designs where you can help with auditing this kind of token issues. So let's talk about some of the FAQs that generally people came across while digging into tokenization. So how can you define tokenization for a layman, right? So I see all different use cases, which is great, but what it is token fundamentally, what is the link between a real world asset and a token blockchain? So it's a digital artifact or a digital representation of a metered resource to some kind, and it could be a great representation or a horrible one. It really depends on how it is attached to that through token engineering, because it's all software. They are kind of like software pointers that they can just point to anything, but strength of that is like what we have to do to consider about that. So can you digitize assets only if they are part of the fund? I mean, is this statement correct or not? So there are definitely technicalities involved, and we can look over to the commodities market, where if you are buying a forward contract for a commodity, it's not necessarily you are buying that literal thing, although there are ones with the deliverables, but most of them are not delivered at the end of the day. So it just depends on what you are trying to do. from a business perspective, and how much of those requirements can we actually meet. I think we get into philosophical discussion about the ownership, and there are better qualified people to maybe answer that question. Another question is, if I want to make a digital identity of a user on blockchain, which contains or validation of all ID, should I use a token for each user? So uh, can a token contain creating digital identity of the user on blockchain? You have to think about it carefully, but probably no. Identity and putting it on immutable blockchain somewhere is a very sensitive matter, because as soon as you tie someone's physical identity to a digital handle, there are a lot of risk involved with that. So we have to think through about information reduction. So we need sort of derivatives, one-time use ID. These are all being thought through a foundation called Decentralized Identity Foundation, which includes participation from people like Microsoft and I think Essential. So are there any use cases in lending, peer-to-peer lending and peer-to-peer borrow? So there are a lot of crypto lending companies out there. I recommend you check out Maker, Aave, Dharma, or Compound Protocol. And I think a lot of actors in the ecosystem already will do lending for covering financial positions and things like that. Within lending, it is interesting for tokenization, because if it is represented as an ERC20 or ERC721, it could be used as a collateral. So you can take a liquid non-fungible asset and hopefully use that collateral, but store it in their accounting system of lending accounting systems as well. One really interesting use case we heard for the enterprise with regard to tokenizing debt, more or less, is basically invoice financing for supply chains. Sometimes there are 90 days I closed on invoices. So 90-day payment cycle are there. And if you subcontract to suppliers, you have smaller suppliers that might be 90 days plus 90 days less. 90 days before you get a payout, if you can tokenize one guaranteed yet to be paid invoice and just issue DApp with that as a backing, that could be more efficient than a lot of systems today physical asset follow. Next is, can we think about concept of creating digital twins for purpose of asset tracking across the supply chain? So the idea of digital twin is that we can basically take some asset like a shipping container or a truck and have a representation on chain across the relevant actors, and everyone can refer to that again. It's kind of like tokenization, that you have to engineer that clue. How do we make sure that this thing is in our digital system actually reflects the real world asset? Maybe there are certain notices. I think there's something called like a bill of lading in freight forwarding industry, that you can have that, can provide provenance for that. But I think digital twins are a great idea, and it has to thought through. Another use case of digital twin is when you map it to automobile. So if you think about a car and the health of a car, the digital twin is its representation. A lot of that has to do with sensors and being able to say this any type of monitoring that's happening, and the real world will also update securely to the digital one. So you can trigger a lot of different things like a vending machine, for example. If there's any type of IoT showing that there's a lack of goods in it, then you can trigger other type of business logics to refill it or do any of those other pieces. So I came across a word called shared data layers. So what does it actually mean? So that can be accessed by all the participants in a network. So by that, I mean in Ethereum, all the data in Ethereum is a part of that shared data layer. But if you have a conservatory implementation, you might want to share some of the things across all participants and redactors. So how does smart contract upgradability factors affect into the architecture design? So it's important to be able to change the things, and not only you need to have a good continuous integration and things to that nature, but also governance process. If you are affecting changes for a lot of people at once, we need to figure out how to make sure it's okay with everyone before we move forward. There are generally two ways to add in different types of whitelisting for upgrade, so that you can upgrade the whole contract. Usually you can use a proxy contract to make sure that you don't lose any of the history, but upgrades in the functionality. But in terms of whitelisting, which is a lot of SEC requires some KYC elements to it, you can either do it in and kind of polymath mechanism, where you have a bunch of registries of smart contract and store all this whitelist that you have to check on. And you can do compliance checks, and you can pause trades or do blacklist of trades of specific account, or you can do it on the protocol level. So ERC 1400 security token really just adds it in as a level. It's into the protocol, and we were able to do partial add in the whitelist there. So what happens in case of tokens representing stock, microshares, or fractionalized real asset? What happens when implied value of the underlying asset based on the value of token exceeds the actual value of the underlying asset, that is the stock itself, or the real estate property? So that really depends on the governance and what jurisdiction you are in, and how do you decide to design it. I think that ultimately there will be issuing parties who have to consider this, so it could vary. There is one of the earlier use case around the tokenizing art and gaining fractional ownership of art. A lot of different companies have looked at it, that piece of art, that there's different ways to do it. If you are a private bank, you may want to tokenize that asset, but making it into actual instrument. So you would only tokenize 49% of it, so that the issuer or that kind of original owner has 51% ownership. And then if that party wanted to buy it back or trade it physically, they may want to pay out for the original. 49% of that is loaned out. So it depends on how you want to design it. So another question is, if a piece of real estate is digitized, how would that be recorded in public registry, deeds, transfers, banking, etc.? So again, this is something which is not coming out from real estate expert, as I'm not one. But in real estate specifically, there's probably a partnership with a lot of other pieces of ecosystem. So you definitely need a land registry that guarantees there's no double spending or double registration. You can imagine someone can take a piece of real estate and just post it in a lot of areas. Like if you have multiple Airbnbs, you just posted your piece of real estate upon them. Then if you have rented it out multiple times, you have to guarantee that it's available at that set of time. The last question from the frequently asked question that I would think of is it a good idea to tokenize non-fungible asset that has an expiration date? So main purpose for tokenizing was for ownership transfer after a buy-sell transaction, and just burn the token once expired. So you can build expiration software into the asset itself, so you can even undo that if there's some clause. So I have got a demo for you to show the token sale, which is also one of the application of tokenization. So I'll just quickly give the demo of that. All right, so this is an token sale example in which I have created a York token, and the smart contracts that I have already been deployed. This is the front end. The link to it will be shared by Joris. Uh, so all is required is for you to enter the number of tokens that you want to buy. You can see that cost per token is 0.0001 Ether. And all you have to do is connect your MetaMask to the Ropsten network. And go to this DApp and just click on buy token. All right, so once we hit confirm, you will see that the token that I'm owning will get increased to 12 when the transaction will get mined. Right, so you can see that the token is now 12, and you can also add that the same token here. All that you need to do is just right click here, open the view source page, and you will be able to see the full code, and just look for the contract address for, so this is a sale address, right? So grab this address and go to robston.etherscan.io, paste it here, and you will be able to see the contract code as well. And if you would like to see where is the token deployed, then go to read contract, and here is the token that is deployed, which is the York token. So click here and you will be see that this is an ERC20 token which has been deployed on Dropston. And similarly, you can access the contract code there. So yeah, that's pretty much about today's session. Thank you everyone for listening patiently to me.
That was amazing. There I am. One of the most thorough presentations I've seen. That was so very info packed. I'm definitely going to have to rewatch that to catch everything. That was amazing. So thank you so much, Dhruvin, for that awesome presentation. And now we want to open it up. If anybody in the audience has any questions, we can take those live now while we have our man Dhruvin here. Also, I want to check in. I'm going to check in on the poll in just a second. Oh, someone says no audio in the chat, but my audio is. Can you hear me, Dhruvin?
Yeah, I can hear you.
Okay, yeah. I'm sorry, Sajed, but everybody else can hear me. I'm not sure. Maybe turn up your volume. Okay. Yeah, so I'm going to take a look at the polls in just a second. So if you haven't already filled in the poll, please drop an answer in there. I got a personal question. So you mentioned a couple of the standards on Ethereum, ERC20, ERC721. I know there's also a standard specifically for securities that is made on there to replicate, traditional financial assets. What other kind of tokens do you see coming down the line? That haven't quite been created yet.
Yeah, so another token that I'm trying to see is a universal token for that can be specifically used for our popular lending and borrowing pools like Compound and Aave, because it's right now it's so very challenging to create such a platform that can interact with all of those different lending and borrowing pools using the same interface. Just that convenience we have it with ERC20, but still we don't have that convenience with our DeFi platforms. So that is the
Right.
thing that I really see.
Cool. Yeah. So like, as I understand it, anytime you deposit into like say Aave, you'll get an Aave specific token back. So if you put in DAI, you get a DAI back. And so you're trying to have a token. So can you explain that a bit more? That an interface that you can see all these tokens. Is that right? Or
Yeah, so the interface could be, so if you talk about, an ERC20 token, we know that we can transfer tokens from one account to another account. So this is one functionality. We can pre-authorize it. We can check the allowances and balance. Similarly, if you talk about landing pools, then the basic functionality that they have is you can invest in, you can borrow it, you can withdraw it, you can enter the market, exit the market, and you can also, place the collateral, withdraw the collateral, borrow against the collateral. So these are a couple of functionalities which you can club together and create an interface. And we can have the variables set in as an argument of the functions in an interface, and that can have its own customized implementation still tied up to the same interface, and that can be very handy to just fire up one contract that implements the interface in order to invest in multiple lending protocols.
I see. I see. Very interesting. Super cool. I don't see any more questions, so I got some more questions I can ask you for myself. So yeah, so most of the action, like you mentioned, is happening on Ethereum in terms of DeFi, in terms of tokenization. So, but there's also that problem of scalability, and like we know, we have the promise of Ethereum 2.0 coming down the line. Hopefully, in a couple of years, it'll be fully implemented. But we also have several kind of contenders in the space for the answer to scalability. So from a technological standpoint, what do you see as, I guess, maybe the most prominent contender, or what kind of projects? I know you mentioned optimistic rollup, ZK, but what specifically do you think is going to be like the forerunner in that space?
I think that's a good question, Joris. So I have been working on it since like a couple of weeks to try to understand how the scalability solution is hitting it's really hard, and what are the solutions that the communities and the startups are coming up with. So the recent news that I heard about was about optimistic rollups, and I can't really comment more on that because it is still in exploration on my side. But what I think is this is what they term it as DeFi 2.0. And basically, optimistic rollup is I'm taking the name because I have seen Vitalik, who is also endorsing this with 100x transactions per second. But technologically, yes, this is a complex space of a code that needs to be made. And also, I'm right now studying how Uniswap has implemented it on the testnet. So what Optimistic is calling as OVM. So basically, how it works is the mainnet Ethereum is only going to act as a proof layer, and all other computations which otherwise are not important to be done on the mainnet will be done by OVM, and there is a bunch of incentive schemes surrounding that. So yeah, I wouldn't be able to answer it more perfectly, but I just answered the information that I had so far.
Awesome. So so that's like there's a difference between, I guess, like a layer 1 solution versus something built on top. So this is a layer 2 solution, is that correct?
This is a layer. Optimistic rollup is a layer 2 solution.
Yeah.
It's
Cool.
a side chain.
Yeah. So do you see that as more the pathway forward to scalability, or layer 1 solution, or is it going to be a combination of both?
So there will be a combination of both, because of course we need the base layer in order to do the settlements is on public. But also at the same time, there is a very big issue on Ethereum mainnet of congestion in the transactions and higher gas fees. So I think there are lots of solutions that have been came previously, like meta transactions, which is another name for gasless transactions. Then it came state channels, and so now it looks like optimistic rollup or any of the scalability solutions on layer 2, which is specifically side chain, will be able to give some promising results.
Awesome. Thank you very much for that very detailed answer. I love it. Okay, let's take a look at the poll here. So we wanted to know what folks' familiarity with tokens were before. And so we have a 50% of folks are saying not much, and that they came to find out a little bit. And then we have a split vote between the third and fourth option. So many people are saying that they know what ERC20s are, and then 25% also are saying they use tokens on a regular basis. And I guess the reason why there's no answers for the second option is because the third and fourth option take into account those that second option.
Yeah, makes sense.
Yeah,
Very
cool. Go ahead.
So all I want to tell the audience, thank you so much for coming in. If you have any questions, I'm really sorry we are running out of time. But of course, my contact details are on the slide deck, and in shortly, Joris will be sharing the slide deck's link with you guys. So you can definitely go over the presentation, go over the recording again. If you have any questions, feel free to reach out to me, connect on LinkedIn. I'm also there on Twitter. You can DM me there as well. And if you are more interested in formally getting to know the concepts of blockchain, we have a very comprehensive course at York University and George Brown College. So yeah, feel free to reach out to me if you would like to know more, and if you're thinking of enrolling in that courses.
Awesome. Thank you so much for tuning in, everybody. Thank you very much, Dhruvin, for amazing presentation. And I think on that note, we will say goodbye for now. But for everyone tuning in, make sure to come back later on this evening. We have another amazing workshop coming up in a few hours. So until then, I will see you in the next workshop.
Okay. See you. Have a good weekend, everyone.